We're going to be leaving behind Chapter 5, which is inverses and logarithms, your favorite. And we're going to be moving into Chapter 6, which is going to be working with polynomials. Now we start off with 6.1, which is going to be adding and subtracting polynomial expressions. So you might be thinking to yourself, hey, what the heck is a polynomial? That seems like a pretty long word. So I'm going to answer that with starting off with something else that's a long word, which is a monomial. So a monomial is when we have a term that is a product of numbers and or variables that are raised to whole number powers. Every monomial has a coefficient, which is the number multiplier, and degree, which is the sum of exponents on the variables. So I have here in this table a bunch of monomials. They're like the building blocks of polynomials. That's why we start with them. Now each one of these has a coefficient and a degree. Let's start off with the first one. So we have 6x to the 5th. Now the coefficient is the numerical multiplier, which is 6. The degree, it's kind of obvious, it's the exponent of 5. All right, so now we move on to the next one, and already we're getting trickier on ourselves because it looks like there's no numerical coefficient. Okay, so you might be thinking 0, but that would be incorrect because if it was 0, there would be no term at all. So it must be that there is a number there, and then it's got to be 1 because 1 times anything is like x squared is just x squared, and then you wouldn't have to worry about writing it because mathematicians are lazy and therefore don't write coefficients of 1 as a general rule. Now degree is the sum of the exponents, and the sum means we're going to add them. So 2 plus 4 makes 6, so that's the degree. All right, now what about the next one? Coefficient's pretty obvious, it's -8, but the degree is a little bit less obvious. There is no power after the one that you have to the n, that you can see, which means it must be 1. Mathematicians don't write powers of 1 because n to the 1 power is just n, so they don't bother writing it. But it is the same thing. All right, and the last one has a coefficient of 5, but there's no variable there, so that must mean a degree of 0, because let's say it was x to the 0 power would disappear and be 1, right? Okay, so now let's string it together for polynomials. Polynomials are when you take monomials and you add them up, so you sum them. The leading coefficient will be the coefficient of the highest degree term, and the degree of the polynomial will be the degree of the highest degree term. Okay, so let's start off. We've got 2x cubed minus 5x. So our terms are 2x cubed, comma, and -5x. Those are your two terms. Now the leading coefficient, I kind of have this backwards. Let's figure out the degree. So the degree of the first term is 3. The degree of the second one is 1. So it's degree 3 because that's the degree of the highest term. And the coefficient, leading coefficient, is the coefficient of the term that has that degree. So the degree 3 term, which is 2x cubed, that means 2 is my leading coefficient because it's the coefficient of the term with the highest degree. Okay, so now what about the next one? 7 minus x squared minus, oops, hold on, I gotta bring that back. There it is. I just need to move this over so I can see what I'm doing here. All right, so I have 7 negative x squared and -6x. Those are our 3 terms. Okay, the degree is 2 because the highest degree term is this one, the x squared. And while I'm at it, not only does it have the highest degree term, it has the coefficient, the leading coefficient, which in this case is -1. Okay. Matter of fact, I'm going to underline up here. I'm going to underline the highest degree term so you can see it a little bit better. Right there. So there we go. All right, what next? Oh, we have a whole bunch of them here. So we have 4xy squared. We have 5x cubed y. We have -9x squared. And we have -2. Okay? Perfect. So, oops, let me go back. Let's underline. This one's degree 3 because that's an x to the 1. 1 plus 2 makes 3, so that's degree 3. This one's 4 because 3 there and 1 there, you add up the powers, 3 and 1 makes 4. This is degree 2, and this is degree 0. So the highest degree is this one. I'm going to underline it right there. So that's our highest degree, so that's degree 4. Remember, 3 plus 1 for the y makes 4. And that means our leading coefficient is 5, even though it wasn't the one on the front. Leading coefficient doesn't mean it's in the front. Leading coefficient means it's the one for the highest degree, which in this case was 5. All right, now next we have negative 9x squared, 4x cubed, and negative 10. Those are our three terms. The highest degree one, kind of obviously, is the 4x cubed on this one. There we go. So what's the coefficient for that? It's 4, and the degree is 3. All right, last but not least, I'm going to make this a little bit simpler myself. I've got 3p to the fourth cube, excuse me, 4p to the fifth, and 8p to the sixth, q to the third. Oop, negative. There we go. All right, so those are our three terms. The highest degree term is this one, which, let's see, there it is. All right, so what's its coefficient? Negative 8, and its power is 6 plus 3. Its degree, excuse me, is 6 plus 3, which makes 9. All right, we're all done with that. So we know what monomials are. Those are single terms, just numbers and variables raised to powers, whole number powers. Polynomial is when you string together monomials with adding or subtracting. Subtraction just means that the coefficient was negative. Right? All right, so now we're going to simplify by adding and subtracting polynomials. By doing that, we're going to be combining like terms. So we want the terms to have same variables and powers. So only like terms can be added and subtracted. You cannot combine things that aren't alike. And you add or subtract the coefficients of the like terms. The variables will remain the same. Okie dokie. So let's get here. This one. So I have 7x squared plus 8x minus 4x cubed minus 1 plus 2x cubed. Whoa, all that stuff. All right. So you might want to take like a highlighter and kind of underline for yourself a little bit. Okay, so we have this one right here. That's an x cubed, and this one right here is an x cubed. So those two go together. And then I've got an x squared right here. I'll give that like a single underline. Oops, let's do like an arrow. There we go. And then this is an x squared, and that gets an underline. There we go. All right, and then we've got an 8x and a 1. And when we write these, we tend to write the highest degree in front. So I'm going to take the two underlined ones, this one and this one. So I have negative 4x cubed plus 2x cubed. That makes negative 2x cubed. There, the double underlined ones are gone. Now I'm going to do the arrow ones next. Negative 7x squared minus another x squared, because there's a 1 here. It's hidden, right? So that makes minus 8x squared plus 8x minus 1. And we're done. Combined like terms. Okay, let's do it again down here. So this one's a bit of a trick question, just a little bit when you look at it, because they put parentheses in it. Oops, I gotta make that smaller. They put parentheses in it, but the parentheses are kind of a fake. They don't really mean anything. It means this whole side plus this whole side. But there's nothing you can do inside the parentheses, right? And the parentheses aren't really required. So you might as well have just said 4a squared, here, this is faster, 4a squared plus minus 9ab plus b squared plus this. I mean, it didn't really make any difference to you that the parentheses were there or not there. All right, now you want to combine like terms. So let me kind of underline these. Let me give this one an arrow. I'll give this one an arrow so you can see them. So those are the two a squared. So they're going to combine together. 4a squared plus another 2a squared makes 6a squared. Then we have a minus 9ab. So let me give that like a double underscore. There we go. And that's going to go with a 3ab. They're like terms because the a's and the b's are the same and they're both raised to the same powers. So together that makes minus 12ab because you have minus 9 minus 3 more. And then last but not least, the two that don't have underlines. B squared, take away 6b squared, which makes minus 5b squared. Oops. And there we go. Done. All right, one more, probably subtraction. Yep, subtraction. All right, that's always harder. So let me copy this. Now here's where the parentheses do matter, because what this is the same as is x squared plus 7x minus 1, nothing different there, minus 4x squared plus 2x plus 8. What I'm doing is I'm distributing the negative, right? So this negative right here has to go to all three of these. It's really -1 times, I mean, if you want to be honest, right? So it's -1 times 4x squared, -1 times -2x, and -1 times -8, right? And so then you distribute your negatives. So I'm going to make a note. Distribute negative, right? And then that gets you here, right here. Now we can just combine like terms. Once you've distributed the negative, this little guy goes with this one right over here, because they're both x squareds, right? So if you have 1x squared, take away 4x squared, that's -3x squared. Then you have your 7x right there, and your 2x right there, which makes plus 9x. And then -1 plus 8 makes plus 7. Done. Oops, your box open. All right, so that's the end of combining like terms. I'll meet you back here for the next video when we're just going to graph some basic functions, basic polynomial functions, using our calculator and our brain. I'll see you then.